Okay, we're looking at the partial fractions mini test and we're on question 3. So we've got an improper fraction here, and I can tell it's improper because the highest power of the numerator is x cubed and the highest power of the denominator is x. So it's a cubic over a linear, so it is improper. But they've told me how it should split up, so that's quite handy. I could do this by algebraic long division, and if you prefer that method, that is absolutely fine. So by that I mean doing that cubic divided by x minus 3, and that will give you that quadratic, and then whatever your remainder is, you just write it over x minus 3, so d would be the remainder. Okay, and that's perfectly fine, that's just as good a way as doing it. I'm not going to do it that way for this question just because we've been looking at partial fractions, so I'm going to sort of stick to a similar method, and that is to think, well, what would I have to do if I wanted to add all those together? Well, they'd all have to have a denominator of x minus 3. So I'm going to treat it just how we have the previous two questions. So that numerator on the left-hand side will equal, so ax squared currently isn't written as a fraction, so if I wanted to write that as a fraction over x minus 3, I would have to multiply it through by x minus 3. Same for the bx, same for the c, and the d already has a denominator of x minus 3, so that wouldn't need to be multiplied by anything. Okay, so what can I do now? Well, if I sub it, I mean, to be honest, you can immediately say what a has to be. So in fact, let's deal with that first, because if I look on the right hand side, if I were to expand all of that out, the only cubed term would be the ax squared times the x. That's going to be my only cubed term. So I can immediately say, from equating the coefficients, looking at the coefficients on the left hand side compared to the right hand side, that a must equal 2. Okay, so I can get that. That's going to be a B1 mark in any exam. You can basically just figure that out without really having to do any working. So we can immediately, let's just sort of write that up here, just through that logic, say that a is 2. Okay, so in terms of subbing in sensible values, well, let's sub in x is 3 and see where that gets us. So the reason I'm using x is 3 is because it will make those brackets equal 0. So if x is 3, I'm going to evaluate what that would equal. So if x is 3, that's going to be 2 times 27 minus 4 times 9 plus 15 minus 1. So I get the left-hand side to equal... okay, didn't mean to do that. Okay, so I get the left-hand side to equal 32. If x is 3, then that is 0, that is 0, and that is 0. So that would straight off give me that d is 32. So let's just keep a list up here of what we've got so far. Okay, so what else could I sub in? Well, I could sub in x is 0. So if I sub x is 0 in, the left-hand side, so that will just equal minus 1. If I sub x is 0 into that, so I would get minus 1. And if I sub in x is 0, then that is going to equal 0. That will equal 0. So I would just be left with c times minus 3 plus d. Okay, so that's what I'd be left with. And I know that d is 32. So I can then say that c is going to be minus 33 divided by minus 3. So c would be 11. So let's go there. Okay, so so there aren't any other sort of values that will eliminate terms. So I've got two options. I could either just choose another easy value, so x is 1 as an example. So I could either just substitute x is 1 in, and because I now know what a, c and d are, I would then be able to find b. Or I could look at the coefficient. So I'm going to do it that way just because I haven't really used that method. Well, no, I did use that method, didn't I, to find a. So let's just use that method again. So if I look at the coefficients, so b is the one that I don't know. So b is what I'm trying to find. So I'm going to look at the coefficient of x squared. I'm just going to quickly jot it down again because I've messed it up a little bit with all my highlighting. Right, so... Okay, so if you prefer, you might just want to substitute in x is 1, x is 2 would work, and do it that way. Let's just try... Let's just really quickly write all this out again. Okay, so we already looked at the coefficient of x cubed. We've already sort of thought about that. It doesn't really look like a cubed, does it? So now I'm going to have a look at the coefficient... or I'm going to look at the x squared term. So on the left-hand side, the coefficient of x squared is -4. Okay, on the right-hand side, well, let's have a think about where am I actually going to get an x squared term. That would give me an x squared term. So that would give me -3ax squared. That would give me an x squared term, bx times b. So that would give me, so I'll try and be consistent with my colours. That would give me bx squared. And then I wouldn't get an x squared term there. I would just get cx minus 3c. And obviously there's no x squared term there. So the coefficients of x squared on the right-hand side are -3a and plus b, and together they must equal -4. If I've lost you a little bit there, then go back to the previous method and just substitute in x equals 1. Okay, and because I know that a is 2, then I can just substitute that in and add the 6 over and get b is 2. Okay, so I think we've got all of our answers now. We've got b is 2, so we've got b, we've got a, c, then d. Okay, so let's just write the final answer out. So a was 2, so and that was the coefficient of x squared. So it was 2x squared. B was also 2, so 2x. C was 11. So plus 11, and D was 32, and that was over x minus 3. So as I said, you could have done that through algebraic long division if you preferred, and you didn't have to do the equating coefficients at the end. You could have just carried on substituting values in if you preferred that method.